All right, so today we are going to continue solving trig equations like we were doing yesterday, but we're going to do a little bit differently. And so what's interesting about this is kind of the title of the lesson is inverse sine and cosine solutions my calculator never told me, which, you know, kind of just to me is the whole point of the lesson. Like, why is the calculator saying this when I want it to say this, or I need something else? Okay, so that's what we're going to talk about. And then tomorrow in lesson 3, we're going to talk about why the calculator does what it does. Okay, so we already know, you've done this since geometry, we've already used the inverse sine and inverse cosine features on our calculator when we're trying to find missing angles in a triangle, right? SOHCAHTOA, we'd set it up, like we already know. And we do know our calculator is only spitting out one answer. But like yesterday we said, trig equations can have more than one answer. And so that's kind of the goal today, is like, how do we deal with that? Okay. So when we solve equations in algebra, algebra 2, pre-calc, we're always trying to get the variable by itself by using inverse operations. And we know that, right? If my x is in a square root, we undo the square root by squaring both sides. If we want to get rid of the 3, we undo the addition and we do subtraction. Inverse operations, remember, are undoers. They undo a function that's there. We're going to use that same idea today to solve trig equations. Okay? So yesterday, or in lesson 6.1, we solved sine of x equals 1/2, like by inspection, by looking at it, right? And we used, this information, like, oh yeah, sine is 1/2, and we got all of our answers from this orange paper. What we never did was we never physically got x by itself. We never got rid of the sign. We just said, oh yeah, we can just solve it by looking. But this wouldn't work for us if I changed this equation slightly and said sine of x equals 1/3, right? There is no 1/3 on my orange paper here for sine. So it's not like we can just solve it by looking at it. Does that mean there's no solutions? No. Let's graph it real quick. If I want to talk about solving sine of x equals 1/3, I'm going to start by graphing a sine curve. This is slightly different graph paper from yesterday. I don't want to spend too much time here. And then I'm going to graph the line y equals 1/3 instead of 1/2. So not much has changed. Just that line is a little bit lower than it was yesterday. So there are solutions. There are 2 of them. But again, it's like, well, where is it? We're kind of like, I don't know, the graph isn't helping me. My orange cardstock isn't helping me. So how do we solve this equation? Are there solutions? Yes. How many? 2 in this particular interval. So we could go to our graphing calculator and graph it and solve, and we will. Actually, let's do that real quick. Sorry, let's go ahead and do that. Let's go find them. So I'm going to go to a graph. I just chose an Inspire, it doesn't matter. I'm going to go graph the sine of x, making sure I'm in radians. I'm going to hit tab, and then I'm going to graph the line 1/3. And then I'm going to go change my window to go from 0 to 2 pi. And then from, I don't know, like -2 to 2. I'm just trying to make it match what's on my paper. Okay. Let's go find these solutions. So I want to find those intersections. So I'm going to click on the left. I'm going to click on the right. All right, so one of my solutions is 0.3398. I guess I could have rounded that to 340, but okay. Oh, I can't see that. I wrote it down. Let's go find our other one. So again, I'm hitting menu 6, 4, and I'm going to click on the left, and I'm going to go click on the right. And there's my other solution, x equals 2.802. So we had to use a calculator to get that. I'm not saying we're not going to use calculators today. I'm just saying we can't solve it without one. Okay? So these are our 2 solutions. They live between 0 and 2 pi. So what I would like to do today is to talk about what is different if we try to solve it differently. What if we don't use a graph? So we have the sine of x equals 1/3, and I'm going to kind of do this here. I just gave myself a little space. I would like to get x by itself by getting rid of the sine. I want to undo the sine. And how do we do that? We take the inverse sine of both sides. Now, we typically don't write that step in geometry. You'd never use that because you didn't even know what an inverse was back then. But the whole point is the inverse sine of the sine are undoers, right? Inverses, and that leaves me with x. And so great, over here, that doesn't really help me, but at least now I can go to my calculator and figure out what that is. Great, so I don't need a graph screen for this. I'm just going to get a regular blank screen, and I'm going to go to my trig button, and I'm going to type in inverse sine of 1/3. And it spits out x equals 0.3398. Well, doesn't that sound familiar? Because it's what we got on the graph. I'm not saying we're going to get different answers. I'm going to say we're going to get them differently. So when we use a graphing method, we can very clearly see how many solutions. If we decide not to use graphs and we try to isolate the x, maybe we're not so sure. Like, we know there's 2 solutions because we've already done the problem, but do you see the calculator spit out 1 solution and didn't give me anything else? Remember the name of the lesson today? Solutions my calculator never told me. I know there's more. I have to go find them. So what are we going to do? We could do a lot of things, but I want to work with the information that I've been given. Before we do anything else, I'm going to grab my pink paper here and just use it for some scrap paper. When we look at the unit circle, here's 0, here's pi. But I'm not going to call it pi, I'm going to call it like 3-ish. Right? Pi, 3.14. And if I go all the way around, that's 2 pi, which is like 3.2 or 6.28, so I'll just call it like 6-ish. What's halfway between 0 and 3? Like 1.5. And what's halfway between 3 and 6? Is 4.5. The reason I'm doing this is just to get in our heads, like when we're working in decimals instead of pi, you should have an idea of where things live. Anything between 0 and about 1.5 is quadrant 1. Anything between 1.5 and 3 is quadrant 2. And I say that because this answer right here, 0.3398, is in quadrant 1. Okay, I'm going to come back to that picture probably a couple times today. All right, so how do we find the other solution? Well, I'm going to go back here. They said sine of x is equal to positive 1/3. If sine is positive, I know my answers need to live in quadrants 1 and 2. So I'm going to go draw that picture. Now, if they have the same sign, that means they're coming from bow tie angles. So let's make sure we draw it with some symmetry. The calculator spit out this angle right here, the one in quadrant 1. That's telling us this slice of pizza is this large. Well, that means this slice of pizza is also that large. I'm going to use my green marker here. So I know I have 2 answers, one in quadrant 1 and one in quadrant 2. I know the name of the one in quadrant 1. I need to go find the name of the angle in quadrant 2. I need to go find that value of that big green arc. So we know this pizza has this value, so we're not going to go halfway around. We're going to go halfway around and then back it off a little bit. We're going to do pi minus my 0.3398. So I'm going to go to my calculator, turn it back on, come on, and I'm going to do pi minus, and instead of typing in 0.3398, let's just arrow up and grab that exact value. Now our answer is going to be more accurate. And I get 2.802 if I round. Now, that should also sound familiar because that was our other answer that we found graphically. We got there differently, but we should get the same answers, right? We're solving from 0 to 2 pi. The calculator spit out one answer. We had to go find the other answer. So we did pi minus our first answer. Okay. All right, well, let's look at this one. It just says solve the equation from 0 to 2 pi By using inverses on your calculator. All right, great. So let's get x equals the inverse cosine of 0.85. Right, that's how I get x by itself. And so I'm going to type that in. Go to my trig button, and I have the inverse cosine of 0.85. My calculator spits out 0.555 if I round. Awesome. Because, well, 0.555 lives in this interval from 0 to 6-ish, right? So there's one of my answers. But we know if this is a cosine equals a positive, cosine is positive in quadrants 1 and 4. That means we're going to have two answers. So I'm going to go draw an angle in quadrant 1, and I'm going to draw its reflection then down there in quadrant 4. This one is what the calculator spit out, 0.555. That's this angle. But that means this angle is also 0.555. I'm going to use my green marker again because we have to find the name of that second angle. We start at 0 and we need to wrap around and find the value of that angle. Be very careful. I'm going to use my yellow marker. We could drop into the fourth quadrant and call it negative 0.555. But this interval says you don't want negative answers. We want numbers between 0 and 6, so we can't give them a negative answer. So we're not going to go drop down into the fourth quadrant. We need to wrap around to the fourth quadrant. So I'm not going all the way around. I need to back off by 0.55. So my other answer is 2 pi minus the answer that our calculator spit out. So I'm going to go 2 pi minus, I'm just going to go grab that number. It's easier and it's more accurate, and we get 5.728. So I'm not saying using inverses is bad to solve equations. I'm just saying you need to be careful that you're giving the information that we're really asking for. So 2 solutions, one in quadrant 1, one in quadrant 4. And we drew a picture to help us get there. We're not really doing a lot of work, right? We're just kind of drawing a picture, using a little bit of brain power. All right, let's do another one. Same thing, same directions, different equation. Sine of x equals negative radical 3 over 4. I'm going to start with that negative. If a sine is negative, that means I have to live in quadrants 3 and 4. Okay, let's just kind of make a little note of that. That means we're going to have two answers. But I'm going to solve for x by taking the inverse sine of both sides. So I'm going to go to my calculator and I'm going to type in the inverse sine of, I'll just grab my fraction, negative radical 3, and then go to the bottom and we got a 4. In my calculator, I'm just going to write that down. Spits out negative 0.448. Oh, wait a second. I can't box that in. They're asking us to give answers between 0 and 6, and it spit out a negative number. That's not even in our interval. Cross it off. Not in the interval 0 to 2 pi. That's a problem. Now, I crossed it off, but I want to still be able to read it because we're still going to use the number. We're just not going to use that number as part of our solution. Let's draw a picture. I'm going to draw it right in here. We know that we should have answers in quadrants 3 and 4, so I'm just going to draw two angles and make them look symmetric. Now, the calculator's not dumb. It gave us information that's going to be useful, but it gave us the angle in quadrant 4 by dropping down into quadrant 4, right? So a negative angle says go down first. So it's not that it gave us an angle in the wrong quadrant, it just gave us a name or a value that's not part of our solution. So let's see. I didn't put the negative in there, but I just drew that arrow that said we dropped down. That's what that negative means. But what that tells us is that this slice of pizza has an angle of 0.448, which means this slice of pizza has an angle of 0.448. We just have to come up with better names for them. So I'm going to use my green marker again. Green is going to be to find the angle in quadrant 3. So I'm going to start at 0 and wrap around. And so to get this angle, it looks like we're going to do half the circle plus that extra little bit. So I'm going to do pi plus 0.448. Actually, let's go do that right now. I'm going to go to my calculator and I want to do pi plus. Now be careful. I'm going to go up and grab that number, but I'm not going to hit enter. Because when I went up and grabbed, that's a negative. So if I did pi plus that number, it's actually going to subtract. I don't want to do that. So you could just arrow backwards and get rid of the negative. That's fine. So there's 3.589. I'm going to go write that down. X equals 3.589. Or if you anticipate that, right, if we really want to add it, we could subtract the negative, right? So you could do pi minus that number, and subtracting the negative will turn it into addition for us. Listen, either way, I don't care what you do there. You just better be careful when you go grab that number that you realize that it's negative, and we don't want it to be negative, okay? Great. Let me get a blue marker here real quick so for a different color. So let's talk about that angle in quadrant 4. I need to find the name of that big blue angle. So I didn't go all the way around. I need to back off by a little bit. So my other angle is 2 pi minus 0.448. So remember, when I go grab that number, it's going to be negative. So I'm going to do 2 pi. I want the negative to be there. So I'm going to do plus, because remember, adding a negative is the same as subtracting. And I get 5.835. And I'm just going to double check with my pink picture here. I have an answer of about 3.5 and like 5.8. Does that make sense? 3.5 lives between 3 and 4.5. That's good. And then my other one was like 5.8. Oh yeah, that's somewhere between 4.5 and 6. So we should double check those values to make sure that they landed where we want. Because if we mess up with our calculator and the negatives, I think that's where we're going to catch it. Again, I'm going to say it one more time. We didn't do a lot of work in here, but like, it's a lot of like thinking it through. And what are we going to do? How are we going to get our answers? So let's do this next one, or this second part. It says, now let's solve the same equation using graphs. All right, listen. We did this as we finished class yesterday in lesson 6.1. You can graph this a lot of different ways. You know me, I like to set things equal to 0. So I'm just going to move that radical 3 over 4 to the other side, because then I want to go graph just one function, and then I want to find the x-intercepts. And again, we're looking from 0 to 2 pi. So I'm going to go grab my calculator. I'm going to go back to that graph page. I'm going to clear out the 1/3. And then I'm going to just change that sign of x to say plus. And then we had a fraction of radical 3 over 4. Okay. What am I looking for? I'm looking for the x-intercepts. So I'm going to go find this 0.
Isabel Penry.
And then I'm going to go find this 0.
3 minutes.
Sorry. And maybe I'll just add a few digits to those. I'll slide them up so you can see them. I'm just going to move this up so we can read it. There's one of my x-intercepts. And there's another x-intercept, right? 3.589, 3.589. 5.835. Done. How fast was that? Right? So fast. And we don't really have to use our brains that much. I'm not going to tell you how to solve trig equations, but really one of the big reasons for bringing this up today is, you know, inverses are a big part of what we do and how we solve equations. And we're going to be using them over the next few days for a variety of things. We just have to understand their limitations. We have to understand what they're going to give us and how we adjust. Okay? All right. Let's take a look at this next one. Now, It says solve the equation on the interval 0 to 2 pi by using inverses or graphs. I'm actually just going to tell us, I would like us to use inverses for this one. I know we just saw that maybe using the graph is easier. Like by far, that's me. But I would like to see, because this one does something a little bit different as well. So we're going to solve this one using inverses. I know you're not happy about that. But we're going to solve for x. So let's divide both sides by -4. And then let's take the inverse cosine of both sides. Right, so I'm going to go back to my calculator, and I'm going to type in the inverse cosine of -3/4. And my calculator spit out x equals 2.419. Okay, listen, I'm going to pause there for a minute. Is that answer in my interval? Well, yeah, 0 to 6, yeah, 2.4 is right in there. Great, let's keep it. Now, where is that answer? 2.4, 2.4, let me grab that pink paper again. 2.4 radians should be somewhere in here. They gave me an answer that's in the second quadrant. Does that make sense? Well, listen, cosine is negative. Yeah, it sure does make sense. If cosine is negative, I need to be in quadrants 2 and 3. They already gave me one in quadrant 2. So when I go to draw my picture, here's one in quadrant 2, and I need to have one in quadrant 3. Look at that symmetry. Make sure your graph looks that way. But they didn't tell me how big this little slice is. They told me this angle right here is 2.419. I need to go find this big green angle. And I don't have this little slice of pizza. And I can go find it. I don't need to though, because if this purple arc is 2.419 and this arc is also 2.419, which means the green arc is the full circle minus that. There's a couple different ways we can come up with this answer, right? This is the one that requires the least amount of work. So I'm going to grab my calculator and I'm going to type in 2 pi minus, and I'm going to go grab that, and I get 3.864. Which, yeah, makes sense because 3.8-ish is in the third quadrant, isn't it? 3.8 lives somewhere in here. We should have two answers, one in quadrant 2 and one in quadrant 3. And that's, yeah. So again, we need to understand how the calculator works, what kind of answers it's spitting out, and be familiar with these decimals, right? Again, we know 0 to 2 pi. 2 pi is about 6. Halfway around is pi. Pi is about 3. Right? So the more comfortable we are with understanding radians as decimals, the easier this will be. Okay? All right, I just want to finish up with this math notes box. Sometimes our math notes box doesn't have much in it. This one has a lot in it. So there are two standard notations to represent the inverse for trig functions. The first one is the one we were using, inverse sine, inverse cosine, which looks like sine to the negative first, cosine to the negative, but we know, we've been talking about that since last year. A -1 exponent with a function does not mean reciprocal. It means inverse. And by the way, that's the next note I have there. Be careful with that. It is not the reciprocal. We have a name for the reciprocal sign. It's called cosecant. Okay. Now, there is another way to write inverse sine. Arc sine of x is the same as talking about inverse sine. So maybe I'll just kind of come down here in green. Y equals sine to the negative first of x, and y equals arc sine of x. Look different, mean the same thing. So we want to make sure we're familiar with that notation.